In this video, you will be learning how to solve the circuits using superposition method. So normally, if you have more than one power source in a circuit, we use superposition method to solve it. So we will create different cases for each power source. So in this circuit, in this example, there are three power sources. So we will take three different scenarios. Just remember that if you will take one power source at one time and other sources, if it is a current source, you will consider it as open. And if it is a voltage source, it will be considered as short. So I'm considering case one, where I'm taking 7-volt source. So you have to redraw the circuit and consider 7-volt source. And whatever other power sources you have now, if it is this is the current source 2 ampere, it will be considered open. And this is 5-volt voltage source, so it will be considered short. So considering one source at one time and considering other voltage sources as short and current sources as open, I redraw the circuit. So I label them and you solve this circuit. So let's suppose current flowing through this circuit is I1. So this is the series circuit. So R total in this circuit will be 2 ohm plus 3 ohm plus 6 ohm because they all are in series. So this become 11 ohm resistor. And I1 will be total voltage, that is 7 volt divided by total resistance. So 7 divided by 11 gives me I1. So I1 is the series current that flows through all series resistor. And since it is a series circuit, current in series remains same. So 0.636 ampere is the current flowing through 2 ohm resistor, 3 ohm resistor, and 6 ohm resistor. So they are all same. Now we will consider second case, that is case 2. In this case, I am considering 2 ampere volt current source. So I will create 2 ampere current source in, I will find how much is the current flowing due to 2 ampere current source in the circuit. So for rest of the sources, if it is a voltage source, it will be considered short. And if there is another current source, it will be considered open. So I'm taking 2 ampere current source and you redraw the circuit. This is how my new circuit will look like. So you see here, this is 2 ampere current source. So I'm considering, let's suppose this is I total. This I total is split into two currents. I'm taking I2 here and I3 here. So 3 and 6 ohm, they are in series because I3 current flows here and I3 flows in 6 ohm. So 3 plus 6 is series, that is 9. So if I redraw this, it will look like so this is 2 ohm resistor, this is 9 ohm resistor, considering 3 plus 6, 9, and then 2 ampere current source. So it's split here I2 and I3. We will use current divider rule to find I2 and I3. Let's suppose this is I total. So current in 2 ohm resistor, that is I2, will be I total times the current in the opposite, resistor in the opposite branch, that is 9, then 2 plus 9. That gives me 2 ampere is the total current, 9, 11. So 18 divided by 11. That is 1.636 ampere. So this is the current flowing through I2. Same thing, we will find I3 current. So I total resistance of the opposite branch, that is 2 ohm, and then adding both resistors that are in parallel. So this gives me 2 times 2 divided by 11. So 4 divided by 11, 0.36 ampere. So we solved the case 2. Now I will consider the third case. So case 3 here. In case 3, we are considering 5-volt source. And redraw the circuit. This is short resistance, and then 2 ampere is current source. It will be considered open, and then you redraw the circuit. 5-volt, 6 ohm, 3 ohm, and 2 ohm. So I'm considering current sources as open circuit and voltage sources that short circuit when considering one source at one time. So if I'm considering 5-volt source here, so rest of the sources, if it is a current source, it will be considered open circuit. If this is a voltage source, it will be considered short circuit. So now let's suppose this current is I4. So they are all in series. So series resistance in here will be 6 plus 3 plus 2. 11 ohm. And current will be, current I4 is 5 divided by 11. So this gives me how much? 0.45. So the direction of current I come from negative, so it will be -5, it will be minus 0.5. If you take the direction of current this way, so this will be positive 0.45. Actually, current is flowing from higher potential towards lower potential. So this is 0.45. But if you take direction this way, that means it is negative 0.45, right? So let's ignore this one here, this direction. So just take the direction in positive direction just to avoid confusion. So just take I4 in this direction. So this will be plus and this will be plus, right? So I4 goes from higher potential towards lower potential. Now, once we have solved all 3 different scenarios, now we will insert the values of current that we have received from 3 different cases in our main circuit. So due to case 1, we got current I1. So I1 direction is this one, right? I1, then 3 ohm I1 here, then 6 ohm I1 here, right? So following this, I could and put the direction of current flow. Now case 2, I2 direction is this way, and I3 direction is this way. I3 here and I3 here. Now considering case 3, I4 direction is going this way, this way. So here it's going this way. So I4 is here. I4 is here. So I4 going this way. So going from positive to negative. So I4 going this way, right? So here also I4 in this direction. Now we have marked all the direction in the main circuit. Now you will find the current in each resistor. So if I can say current in 2 ohm resistor due to all the sources is I4, I1. They are both in same direction. So I will take I4 plus I1 minus I2 because I2 is in opposite direction. So since I have took the direction of I4, I1, so that means the actual current that flows in 2 ohm resistor that is shown by black mark here, that will be, I'm taking in the direction of I4 and I1. So enter the values of I4. I4 was 0.45 plus I1, that is 0.636 minus I2, that is 1.63. So let's do the math here. That gives me 0.45 plus 0.636 minus 1.63. That gives me negative 0.54 ampere. So it shows me that current flowing in 2 ohm resistor is 0.54. It's negative. That means I assume the direction of current flow in this way, but actually the direction is opposite. So minus 54, minus 0.54 represent my direction is in this direction. That means it's minus 0.54. But actually it is in opposite direction. Same way, let's find the current in 3 ohm resistor. So let's find here current in 3 ohm resistor. Direction of I3 plus I4 plus I1. They are all in same direction. So adding them all. So I4, I3 is 0.36 plus 0.45 plus 0.636. So that gives me 0.36 plus 0.45 plus 0.636, 1.46. So it's positive direction. That means the direction of current that I assumed is this one in direction of I3, that is correct direction. So that represent the actual current flowing through 3 ohm resistor due to all 3 different sources. Right. So same thing for 6 ohm resistor because they are in series. So 3 ohm and 6 ohm will have same current I4, I1, I3 added. So that will be 1.46. So current in 3 ohm and 6 ohm remains same. So this is how you solve the circuits using superposition method. Thank you.